I will press the Windows key and the right mouse button to kind of swiftly position or place this in next to my schematic. I like to have these two open simultaneously, and you'll see why as we start routing. Great, let's save changes. And just as the schematic, you can edit the info, you can press the dates on, you can do revision 1, title, STM32 prototype board, company, my company, comment, could be the name if you want, you can put your name on there. Okay, so now we edited properties on the page info. And actually, to begin routing, we will need to import everything from our schematic. So there's a button here called Update PCB with changes made to schematic. We'll click there. There'll be a little window, and it'll show you everything that's going to happen. So it'll process all the symbols, add the footprints, and that's exactly what we want. We click Update PCB and close. And all of our parts are now going to stick to our mouse cursor, and I can just click and place everything out onto the sheet. So as you can see, everything is selected. So that's the cool thing about having the schematic and the PCB routing tool open at the same time, is if I click here, it'll highlight the MCU here. If I click on this resistor, it'll find the resistor here for me. So I can just press M and I can move it around. I can click on the MCU, I can click M. This is going to be our central components, so we might just want to put this in the middle. And let's give ourselves some space and kind of move this away a little bit. Let's kind of move our parts around a little bit. The cool thing is you can see where they connect to, which is going to help us with the placement. You can press R to rotate as well. If you ever feel like something is tangled up, rotating it might help loosen up some of the nets for you. So before we even get to routing or placements and so forth, let me just go over the layers tab here. So we will have 2 layers. You can click on the edit board setup here, and we'll get a bunch of properties here we can change. Physical stack up here is where you can change how many layers you want. 2 is just fine for us, it's a lot cheaper. Here's the FR4 dielectric material with the epsilon permittivity coefficient value. Here's the thickness, and we don't have to do any changes here. This is just, and here's our 2 main layers, the F front copper layer and the bottom back copper layer. So let's press OK, and those layers will be highlighted and displayed here for us. Whichever layer we click is the layer we will be drawing on. So if you want to add text onto the PCB, you can press the front silk screen or the back silk screen if you want something written on the back. As for right now, let's just click the edge cuts layer and then click the draw a rectangle, and let's just encapsulate our components like so. Press escape, click anywhere on the sheet. This is now our board outline. So if we go to view, 3D viewer, this is what we have so far. So on the edge cuts layer is where you'll be able to kind of draw your PCB. So let me just do an example. It's quite obvious. Let's just capture the whole PCB like this then. And now let's return to 3D viewer. So you can draw kind of your own board.
I noticed an error. It says SW clock on both nodes, so we gotta fix that. We could put an actual mechanical switch here. It may be much better. We're looking for SPST, so just add a symbol and type in SPST, which means that we can disconnect the reset, remove the test point, remove all of this. And I guess we can keep the test point there. Let me just edit the symbol, move this pin around a little bit. There we go. Okay. Let's assign a footprint to this part. So let's double click footprint.
So I actually can't find this switch solder pattern. But that's okay. We'll make our own. It's kind of the same process here. Go to this KiCAD menu, go to footprint editor, and here we are. We're going to need a new part. Create new empty footprint. That's where we're going to go. The footprint name, SMB, SPST,
button. Let's just call it that.
I spelled button wrong, just realized. Let's rename that to button. The grid is too fine, so let's bump up the grid a little bit. 0.1 is great. And let me just create a box. Any kind of box. We know that it's gotta be 4.2 tall. So let's go negative 4.2 minus, or divided by 2. Okay, so 2.1. Actually, that's the y direction, so negative 2.1, 2.1. And this one is 6.8, 3.4. Okay, so that should be, it's 4.2, great. 6.8, excellent. Then we have a line that will be 1.1 tall, 3.7 wide. So what is that? Let me just do a line, double click on it, starting point X, and it is 3.7 divided by 2. Alright. Copy that, paste that there. Okay. So the pads should sit. So let's add a pad, double click on it. 1. The size is in the X direction 6.8 minus 3.7. In the Y direction 4.2 minus 2.2. Okay, that's our pad. That's impossible. So what went wrong? Let's create a rectangular. I see, you have to divide that by 2 further. So that's 1 divided by 2. There we go. Now that is a pad, and it should go here. Let's change the pad number to 2, 3, and 4. Let's measure to confirm that this is right. So between these two should be a distance of 3.7. So it's 3.65. Could be that this one needs to move one more step to the right. Okay, so that's our switch footprint. What can really help in drawing these is to build these templates and kind of supporting silkscreen structures. And of course you can measure 6.8, perfect. This should be 3.7, yes. Great, so that's our button. Let's save that. Yes, here, my project button. Yes, there you go. Finally added it. Great, we go to the footprint assignment tool, everything has a footprint, apply, great. Now let's jump back into our PCB editor, import all those changes. Yes, okay. So here's our switch now. Great. So if I press Alt 3 to go into my 3D viewer, we see that everything has a 3D symbol except the switch. So let's add that. So I'm on DigiKey here. Usually you can go to the manufacturer, and sometimes they have the 3D model, which is great. CNK distributor. CNK switches, and let's search for this part, manufacturer product number. So let's copy that, enter part number, looking for a tactile switch. What is this one called exactly? The PTS 647. Okay, here it is. Click on it, and if we're lucky, they have a 3D model for it. This one. Yes, that is the one. 3D model, great. Okay, so it does look like you have to create an account, so I'll just have to do that. Okay, so there's a lot of options to choose from. We need an STP file. Here we have a step file, so let's go with that. And let's start the generation. Save this. We've extracted it. Go back to the PCB editor, double click on the switch, 3D models tab, and here we have to add a path. Click the folder, add the step file, and here we are. It doesn't look great just yet. We have to make some transforms. So let's rotate this and let's just try. So we rotated it 90 degrees in the Y direction. Now let's rotate it in the X direction. There we go. Boom. And it fits right onto our solder pad. I'm happy with this. This looks kind of nice. Fits right on. Great. Press OK. Now when we go back to our 3D viewer, we now have our little button too. It's not colored. It's just a simple 3D model, I guess. But the nice thing is, usually manufacturers have a 3D model of their component that they almost always put out, and most times you don't even have to register. And for this switch you had to, but sometimes you don't even have to do that. You can just get the STP or step file and import it into your schematic. Great, so we're making a lot of progress.